Hello all, welcome to this lightning talk. I will talk about face composable. And I'm Sinan Kozak. I'm a staff Android developer at Delivery Hero. I am also a Google developer expert. I'd like to talk about performance since I'm also working on the performance-related topic in our company and in my side project as well. I'm not bored of Android development thanks to all of the low-end devices and the problems they create to us. Today, I would like to talk a problem that you might be familiar or not be familiar of. It's the compose first frame render issue. And the compose is not special in this case, but being able to draw the first frame, compose needs to do lots of things to understand what's on the screen. And the content is dynamic, and it's not be able to optimize until it's able to read everything. If you look at this problem, if you look at this problem from the benchmark perspective, it's also proven. Even with the same amount of content, Compose's first frame is slower than the views itself. And the reason might be like different things, optimization, not being able to load the library as operating system, but there's also other problems. And this kind of first frame issue becomes much bigger problem when the content is much more richful. And it is something not just for the first frame, but it shows itself for every individual contentful frames because Compose needs to I didn't do anything. Compose needs to do multiple steps before being able to show the first frame. It needs to do the composition, which includes the UI elements, scaffolds, headers, filters, and anything on the screen needs to be composed, and all of those functions needs to run. Then all of those functions do layout and measurements and the placing based on their calculation. Before doing all of those phases, like layout and the measurement, Compose has no idea if a component will be on the screen or not on the screen, so it will not be able to do any of the drawing or any of the optimizations of the drawing phase. But if you look at this one, this is from our application from last year, from our benchmark test, which was using 2-year-old Samsung device to be able to do that. The reason is that it was not optimized. Every team just put their features. There were lots of lazy layouts, lots of columns, animations. Multiple things were cached unnecessarily on the UI. A couple of campaigns were loaded eagerly because they wanted to get their promotions and they wanted to get their campaigns to be seen on the main screen. But initially, what ended up happening, our first contentful frame start having problems, visible problems. This was not an issue of scrolling. This was not an issue of fitting our frames to the 16 milliseconds or lag, but it was like a specific problem that was not yet fully addressed by the Compose, which it cannot fully optimize because there are runtime changes. It will not have any idea about what kind of content needs to be put on the screen. If it was an XML, it might have an understanding of, hey, what is the content? But for Compose, everything needs to run. This led the different kind of problem for us, like frozen frames and ANRs in the extreme cases when the device were slow, their CPU is old, their operating system is old, they might be on the power saving, and there are different other problems that could increase the chance of hitting any of those problems. And interesting part is, while these frames are drawing, main thread is busy. That means even if you would like to just assign a single value or change flip a boolean, main thread won't be able to do it until that frame is fully rendered on the screen. This could lead to rage clicks and interesting crashes on the application because the time the user clicked and the time that click is actually handled on the main thread will be a different set of UI element, and that could lead different exceptions. We had multiple null pointer exceptions coming directly from the composable because the time that click listener is handled, some of the compose elements were visible on the screen, were actually removed, and they were cleaned up by garbage collection, and it could lead problems that we were never imagined. But to be able to solve this problem and overcome, we got some inspiration from the history. For example, Android had the view stuff to be able to dynamically load the content, expensive content, on demand. But that was a manual effort. Web has hydration technique, which they send important content that is usable for, like important for the user, early in the HTML stage, so user can start seeing the navigation, header, loading, or some of the text, whereas the images and the JavaScript content or any other big component can be streamed later on. Games are using this technique since we start developing, like everyone start developing games on the machine, because in the games, the developers would like to show multiple high detailed content, whereas the resources are limited. And the industry showed this trick to us in multiple stages. If you look at the GTA 3, sorry, I have been accused of living in Germany too long for saying GTA. So Grand Theft Auto had to fit in the PlayStation 2. And PlayStation 2 has only 32 megabytes of RAM, which needs to be shared with the rest of the operating system and the operating system of the PlayStation. And their full 3-island map contained all of those textures, meshes, equal to 130 megabytes. So they were not able to fit everything. What they did is an amazing technique of only loading things that are visible to the camera perspective, not even the player perspective, camera perspective, because the game changes the camera time to time. So if they were using the top-down approaches to be able to load less things rather than showing first-person action to load more things. But this helped them to fit in the memory and also helped them to have an immersive experience. Same thing goes to the web as well. For the slow networks, it is really important to be able to show the first meaningful content to user. And if web components are sending a small HTML containing some of the text or loading, user will have understanding of something happening on the device, and the rest of the content, especially the dynamic part like click listeners or animations, can be loaded later by streaming on demand. To be able to solve this problem, in Delivery Hero, we worked on the different solutions. I created face composable. We call it face composable and sometimes face rendering, because leadership doesn't know much about the compose, so we had to make it presentable. So you might hear like face rendering or face composable throughout this conversation, but they are interchangeable. Our idea was we would like to start showing and make content available to user early as possible. So to be able to do that one, we needed our content loaded on the screen face by face. Ideally, in each frame, we would like to show some part of the UI and some part of the application, and say leave spaces in between so main thread could start operating and start doing their operation. And if there needs to be any changes, they will be reflected before even the first content is ready. This is how our Perfetto traces look like afterwards, rather than having one or two really giant 600 to 700 millisecond frozen frames. We now have multiple slow frames. This is a trade-off that we agreed on. Rather than having frozen frame, now we have multiple slow frames, so converted the problem to something else that we can work on. It doesn't mean that we are not working on an individual component to improve their performance, but the sheer amount of things needs to be put on the screen, especially some stuff coming from our design system. We needed to be creative about how we can do this optimization. And this is how the API looks like. The initial API started as like global values, if checks on the composable elements. We try to control the visibility, but it led multiple synchronization issues and caused our some of the components appear at a similar time. So that's why we created a face container to take the control of the synchronization and reveal operations. It exposes a face context lambda, which every container component internally can wrap themselves by just calling a face. What ends up happening, each of those phases are registering themselves by the key at the time they were actually called. I specifically didn't put any order or any input that could indicate what is the order, because when we read it, what I would like to have is it just loads in the phases when they are actually called, like they are executed sequentially. In this example, in the first frame, phase container will put itself, anything not wrapped in the phase will be also put on the screen, then the header will go first. It will put some information to user, then the main content, and anything that are not directly related to our main business can come up later, like advertisements, campaigns, map, or any warm-up logic that we would like to run could be put in this category. And under the hood, what ends up happening, each of those phases register themselves to the state. Whenever there's a new registry, which happens in the first run, multiple things are registered. An internal phase can also have phases to reveal more, register more component. What ends up happening is a snapshot flow is being recreated, not recreated, but recollected, and it's keep tracking of the size of the phases. That means phases can be removed or added. And this only happens for the first frame, and afterwards, none of those logics does anything because when we reach the target frame, we don't care. And the trick is we want those components to become available frame by frame. And each frame, there needs to be a phase that we control of, that we know that it's important, that needs to be go to pipeline first. And with frame nanos, help us to suspend our Kotlin here until the next frame is available. When the next frame is available on the main thread, we just trigger the current frame count, and that help us to reveal the next phase, which is rendered on the screen. Before the phase composable, what end up happening, our splash screen, let's say that 1000 milliseconds. We had to wait a little bit more because Android first frame is special. The splash screen continues to stay on the screen until the first draw operation of the new activity finishes. That means even if, like when you load your teams, compose, and all of the component in the first frame, including the shaders and whatever the render thread is doing, the user will not be able to see it. Yes, they will see a full content, but in our case, it was taking more time than we would like to have. Later, when we put a skeleton, this also takes some time, and even if we have data from the cache, it takes a lot of time for the compose to be able to run, execute, layout, and draw things on the screen. And this took the measurable amount of the time. And this weight gap is the perfect trace that I showed in the beginning. And after phase composable, what end up happening, our first frame just loads the theme and the bottom navigation for the scaffold as well, which is lightweight to go. So it becomes visible earlier. Later, on top of it, skeleton becomes available. Whenever we are able to map our cache data to the UI, it also becomes available one by one by putting some skeletons or filters on the screen or like placeholders. Later, the rest of the component slowly comes up, and it gives a feeling of application is loading something dynamically rather than waiting on the device resources. Because at that moment, around 1,300 or 1,500, we actually have the data. We would like to make it available as early as possible. And this is a really slow device example. On the fast devices, the user doesn't even know. It just looks like a really fast reveal animation happening in a couple of frames. But on the slow devices, it's very visible. I wanted to show you a video, but since it's a lightning talk, I don't have enough time, which I also need to speed up. So this help us to reduce our frozen frame 25% for the home screen alone, and the time to interactive metric also improved in the initial implementation. Later on, we improved and made it available to other screens. So most of our core business screens are using this technique to be able to show the content early as possible and reduce the frozen frame. This is helping us a lot. That's why we would like to open source. And then if you think that you have the similar problem, or you think that it will be beneficial for you, or just for if you have a feedback for this one, how you feel about this lightning talk, because I tried to squeeze lots of information in 15 minutes, which I have 15 seconds left. You can scan, and I would like to thank you all. And I'm happy that I made it in 15 minutes, not 40 minutes like rehearsal.